Hello and welcome to this video. So I missed that new Python release has been done. I overlooked this last time. So this is version Python 3.13 has come. You can go and read what has changed in this. The most important change is PEP 703, which is it has experimental support for running with GIL disabled. So you can look at this pre-threaded CPython. So this would be a massive performance increment, and plus there is an experimental JIT compiler is coming in. So these two, once they will be complete, they will graduate from the experiment incubation. It will basically make Python a lot more performant. Right now Python is very slow. So make sure you go and read this. While we will continue with the library reference, we were supposed to read strings. So we start with strings. Now there are certain constants here defined, string dot ASCII letters. So the concatenation of ASCII lowercase and ASCII uppercase. So if you want, you can see it contains A to Z and A to Z. So for example, print this. We'll have to import string. Okay, so if you want, I can run this python docs.py. There you go. Similarly, we have ASCII lowercase, which will be A to Z, lowercase, ASCII uppercase. We have digits, we have hex digits, which will include 0 to 9 and 8 to F. Capital, small, both. Octal digits is oct digits. There are punctuation marks, which are other symbols on the keyboard. Printable is the list of ASCII characters, punctuation, white spaces, and digits. White space is character space, tab, line feed, return, carriage return, CR code, form feed, and vertical tab. Now, formatter, I think we had covered it, but anyway, let's go through it again. The built-in string class provides the ability to do complex variable substitution and value formatting via the format method described in PEP 3101. The formatter class in the string module allows you to create and customize your own string formatting behaviors using the same implementation as the built-in format method. We have covered the format method. So formatter class has these methods. Format, this is the primary API method. It takes a format string and an arbitrary set of positional and keyword arguments. It is just a wrapper that calls vformat. So we won't use vformat directly, we use format. So it does the actual work of formatting. It is exported as a separate function for cases where you want to pass in a predefined dictionary of arguments rather than packing and repacking the dictionary as individual arguments using the star args and star star KW args syntax. vformat does the work of breaking up the format string into character data and replacement fields. It calls the various methods described below. In addition, the formatter defines a number of methods that are intended to be replaced by subclasses. One is parse, which takes the format string, loop over the format string, and return an table of tuples. Literal text, field name, format spec, and conversion. This is used by vformat to break the string into either literal text or replacement fields. The values in the tuple conceptually represent a span of literal text followed by a single replacement field. If there is no literal text, which can happen if two replacement fields occur consecutively, then literal text will be a zero length string. If there is no replacement field, then the values of field name, format spec, and conversion will be null. Get field. It takes a field name and args and KW args. Given field name as returned by the parse, convert it to an object to be formatted. Returns a tuple object, comma used key. The default version takes strings of the form defined in PEP 3101, such as 0 name or label.title. Args and KW args are passed into V format, the return value used key has the same meaning as the key parameter to get value. So now we see get value. It retrieves a given field value. The key argument will either be an integer or a string. If it is an integer, it represents the index of the positional argument in args. If it is a string, then it represents a named argument in kw args. The args parameter is set to the list of positional arguments to V format, and the kw args parameter is set to the dictionary of keyword arguments. For compound field names, these functions are only called for the first component of the field name. Subsequent components are handled through normal attribute and indexing operations. So for example, the field expression 0.name would cause getValue to be called with the key argument of 0. The name attribute will be looked up after getValue returns by calling the built-in getTTR function. If the index or keyword refers to an item that does not exist, then index error or key error should be raised. Then we have check unused args. Implement checking for unused arguments if desired. The arguments to this function is a set of all argument keys that were actually referred in the format string, integers for positional arguments and strings for named arguments as we have seen, and a reference to the args and kw args that was passed to V format. The set of unused args can be calculated from these parameters. Check unused args is assumed to raise an exception if the check fails. Then we have format field, which takes a value and format spec. It simply calls the format built-in. The method is provided so that subclasses can override it. Then we have convert field. It converts the value returned by get field given a conversion type. As in the tuple returned by the parse method, the default version understand S, str, rep, and ASCII conversion types. Format string syntax we have covered, and as I had said in my previous video, we will not cover. This is the format specification mini language. It covers that. So this is the format specification mini language. We have covered it. So we will skip format examples. I'm not sure if I have covered it, but most probably I have covered it. In any case, it's very simple and you can read on your own. So I will go and start with template strings. Template strings provide simpler string substitution as described in PEP 292. A primary use case for template string is for internationalization, since in that context a simpler syntax and functionality makes it easier to translate other than built-in string formatting facilities in Python. As an example of a library built on template string for i18n, see the flufl.i18 package. Template strings support $-based substitution using the following rules. $$ is an escape. It is replaced with the single dollar. Dollar identifier names the substitution placeholder matching a mapping of key identifier. By default, identifier is restricted to any case sensitive ASCII alphanumeric string, including underscores that starts with an underscore or ASCII letter. The first non-identifier character after the dollar character terminates this placeholder specification. $identifier is equivalent to $identifier. It is required when the valid identifier characters follow the placeholder but are not part of the placeholder, such as nounification. So let's see some examples of this. Okay, let me remove this. So how you do it, suppose we have a variable 5 and we want to say that the number is 5. So you use backticks. The number is $x. Okay, and this should do. Okay. We call it y. Oh, I am making mistake. This is not syntax. It should be start with capital F and end with capital F. And yeah, this is what we'll do. So let's see if this works. Okay. You don't need $. No. You need $. So I don't remember this is template string. Okay. Let's see PEP 292 a bit. Okay. Dollar. It uses template function itself. Okay. What I was showing was of F strings. This is F string, not template. So this is F string here. This is not template strings. Okay. So you can say the number is X and it will print number is 5. So for templates, we can say from string import template, and then you can say template, the number is $x, and this should work. Okay, so for printing it gives the object. All right, all right, so we'll see. So it gives you the object, and then what we can do with the object, we can figure that out. I never use template strings. Let's see. We say print y dot. Okay. Y dot template. Let's see what it prints. So that is the template dot. These are the functions. Okay. So this is a string function. So it will have all the functions of string. Okay. So we convert it to a string and then we try to print it. Okay, it is still says string template object. We'll see if there is a method here. So we have a constructor which takes an argument which is the template string. That is this template, we used it. Then we have substitute, we take a mapping with key W substitutions, performs the template substitution, returning a new string. Mapping is the only dictionary-like object with keys that match the placeholders in the template. Alternatively, you can provide keyword arguments where the keywords are the placeholders. When both mapping and keywords are given and these are duplicates, the placeholders from the keywords take precedent. Take substitute is like substitute except that if placeholders are missing from mappings and keywords, instead of raising a key error exception, the original placeholder will appear in the resulting string intact. Also, unlike the substitute, any other appearances of dollar will simply return dollar instead of raising value error. While other exceptions may still occur, this method is called safe because it always tries to return a usable string instead of raising an exception. In another sense, safe substitute may be anything other than safe, since it will silently ignore malformed templates containing dangling delimiters, unmatched braces, or placeholders that are not valid Python identifiers. Each valid returns false if the template has invalid placeholders that will cause substitute to raise value error. Get identifiers return a list of valid identifiers in the template in the order they first appear, ignoring any invalid identifier. Template instance is also provided one public data attribute. Template is the object passed to the constructor's template argument. In general, you shouldn't change it, but read-only access is not enforced. So the example is given here. We import template from this, and then we construct a string $who likes what, and then we substitute who with Tim and what with Kung Pao. So who will become Tim? Tim likes Kung Pao. So that is the string. And then we have a dictionary. We create a dictionary where who is Tim, and we create a template, give $who $100. So we substitute this with D, and the problem is $100 is invalid placeholder because the identifier 100 does not start with uh, a letter, ASCII letter or underscore. So this is bad placeholder. Then we have another template $who likes what, and substitute with the same dictionary In this case, what will not have a matching key in the dictionary D. So there is a key error. If you do save substitute, then $who becomes Tim and likes $what. So I don't see many uses of this in real life. Mostly F strings are used. In any case, we proceed further. Advanced usage, you can derive subclasses of template to customize the placeholder syntax, delimiter characters, or the entire regular expression used to parse template strings. To do this, you can override these class attributes. Delimiter, this is the literal string describing a placeholder introducing delimiter. The default value is $. Note that this should not be a regular expression, as the implementation will call re.escape on this string as needed. Note further that you cannot change the delimiter after class creation, that is, different delimiter must be set in the subclass's class namespace. So we have ID pattern. This is the regular expression describing the pattern for non-braced placeholders. The default value is the regular expression. I cannot explain it right now unless we cover the regular expression. So you have to wait. Same with the brace ID pattern. This is the like ID pattern, but describes the pattern for braced placeholders. Defaults to none, which means to fall back to ID pattern. If given, this allows you to define different patterns for braced and unbraced placeholders. Flags. The regular expression flags will be applied when compiling the regular expression used for reorganizing substitution. The default value is re.ignore case. Note that re.verbose will always be added to the flags, so custom ID patterns must follow conventions for verbose regular expressions. Alternatively, you can provide the entire regular expression pattern by overriding the class attribute pattern. If you do this, the value must be a regular expression object and with 4 named capturing groups. So I will skip this part and maybe I will come back later once I have covered the regular expression. And then we have a helper function. String.capwords s comma separator is equal to none. Split the arguments into words using str.split, capitalize each word using str.capitalize, and join the capitalized words using str.join. If the optional second argument separator is absent or none, runs of white space characters are replaced by single space and leading and trailing white spaces are removed. Otherwise, separator is used to split and join the words. So this can be very simple. So for example, you can say we will have to import string, and we say string dot cap words, and we pass it and string. We give a leading space, and then we give a trailing space, and then we put more spaces, and maybe we put a tab here, and let's see what it does. And we print this. So according to our logic, these multiple spaces should be one space, leading and trailing white space should be removed. Yeah. So one space everywhere and each word is capitalized now. So that's it. And next topic is regular expressions. Now we are going to spend quite a bit of time in regular expressions. Maybe I don't know how many videos I will make on this. It depends. So there is we will see a lot of examples in regular expressions other than the documentation. So stay tuned and wait for videos for day after tomorrow. I'll start first. I will go through this and then I will follow the examples. So this may take 2-3 days for me to cover, and after that I will start giving examples. So this is a very important topic, as regular expressions can be quite nasty, but we'll see. So I hope that you are enjoying this series of videos and you find this video useful and informative. So once again, thanks a lot for watching. Happy programming.